we are going to expand from the unit circle to any angle. So we're going to get a slightly new definition for all of our trig functions, just considering the case where we're not on the unit circle, so the radius is not 1. So you guys have these definitions in your slides. I know you've read them already. So they look very similar to the definitions that we had in the last, 2 sections ago. Except now we are including R. We didn't have to worry about R before because R was equal to 1, but now if we're not on the unit circle, R could be anything. So now we need to include it in our definition. But you can calculate R if you know X and Y, just using, a variation of the distance formula or Pythagorean theorem to find R. So you're just taking the square root of x squared plus y squared. So sine still relating it to the y coordinate. Sine is y over r, cosine x over r, tangent still y over x. All the others are still reciprocals. So very similar to what we had before. All right, so let's see how we use these definitions. If we are given a point, so notice that this point is not on the unit circle. It is outside of the range of the unit circle. Those coordinates were always between -1 and +1. This is the unit circle. And we're looking for sine, cosine, and tangent. So they give us x, they give us y. And the only other piece of information that we need is r. So let's find r. So r is the square root of x squared plus y squared. We know both of those. X is -3 and y is 4. So just put those numbers in place of x and y. I'm going to evaluate this. Using order of operations, make sure you do the exponents first, and then multiplication, division, then addition and subtraction. So we're going to do 9 plus 16. That's the square root of 25. And the square root of 25 is 5. So r is equal to 5. So now when we find sine, remember sine is y over r. So we are going to take our y coordinate 4, put it over r, which is 5. So 4 over 5. 4 cosine, this is x over r. Our x coordinate is -3, and r is still 5. For tangent, tangent is y over x, so 4 over -3. So here on the side, we've got a little graph of the information that we're given, the terminal side of this angle, the point -3, 4 is on the terminal side of this angle, and -3, 4 is in the second quadrant. So we kind of double check if that makes sense for what we know about the signs of our trig functions. In the second quadrant, that's the S quadrant, so sine should be positive, but cosine and tangent should both be negative. And that matches what we got here using this definition. You can also think about, if you prefer the triangles, you dropped a perpendicular and made this into a right triangle. This length right here is 3. This distance here is 4. You would have to make sure you pay attention to the negative and the fact that you're in the second quadrant, but you could use the triangle definitions. You could do opposite over hypotenuse. All of these are different ways to do the same thing. Now let's say we were not given an ordered pair. We're just given a value for one trig function, and we're asked to find the others. So we kind of did something similar to this earlier, where we would use, we could use a triangle or an identity to solve this. But let's use our definitions from this section 1.4 and this information that we're given here. So let's remember which functions are positive in which quadrants. All right, so in the first quadrant, all of the functions are positive. In the second quadrant, sine and cosecant are positive. In the third quadrant, tangent and cotangent are positive. And in the fourth quadrant, cosine and secant are positive. Okay, so they've given us a value for tangent that is negative. So I know I'm not in the third quadrant, I'm not in the first quadrant. And they also tell me that cosine is positive. So that tells me that I'm in the fourth quadrant because cosine is positive, but tangent is not. So I'm not in the first quadrant because tangent is not positive. Only cosine is positive. That lets me know I'm in the fourth quadrant. So when I find sine and secant, I know that sine should be negative, secant should be positive. So why is this important? This is important because we're going to use the definition that tangent is equal to y over x. And so we could say that 5 is y and 4 is x. One of them is negative, and we're not sure which one. Because negative 5 over 4 is the same as negative 5 over 4, which is the same as 5 over negative 4. So the top could be negative, bottom could be negative. They're just not both negative. Right, so we're going to keep that in mind as we go along here. So we're looking for sine. Sine is y over r. And then we're looking for secant, which is the reciprocal of theta. That's important. Secant is the reciprocal of cosine, so that is r over x. Okay, so writing out those definitions, I can see that I need to know r. So let's find r using x and y. In this definition, it's not important whether x or y are negative because we're going to square them anyway. So they would come out positive once they're squared. All right, so there I have r. I'm just going to leave it as the square root of 41. All right, so now for my answer, I'm in the fourth quadrant, so sine needs to be negative, so that y needs to be negative. So negative 5 over the square root of 41. And then secant is the square root of 41 over 4. In the fourth quadrant, secant should be positive. All right, so remember, it's not important where you put the negative, just if the negative's out front, if the negative's on the top or on the bottom, then the whole fraction is negative. Also notice that depending on the question or the instruction, the circumstances, you may have to rationalize this denominator on this answer.